Hi, everybody. Thank you for joining me today and on our PowerShell deep dive into parameter binding. Before we get started, a big shout out and thanks to our sponsors that make this whole thing possible. None of us would be here without them. So thank you. A bit to me, I'm Fred, cloud solution architect at Microsoft, previously known as Premier Field Engineer, and I had the lucky fate that I managed to convince all of my customers to make me do PowerShell. So I get to play a lot with my toys and get to see a lot of edge cases, a lot of oddities out there. And I get to refactor a lot of scripts, see a lot of habits and practices, and get a lot of questions about why is this not working, or the ones that I find are really a lot more interesting. Why the hell is this working? This can really be hard to troubleshoot because it's a trouble that you're shooting. So we are going to look today at two real aspects about this whole thing. We're going to look at the binding process. How do we find which value goes to which parameter? How does that whole work? And then we have another major part about parameter binding, that is how to make the type work. In PowerShell, in opposite to most other programming languages, we don't need to specify exactly the right time a type. PowerShell will try to make it work for us, kind of as an entry accelerator for admins and to make our scripting life easier. The problem is, easier is really, really relative when you go deeper into the rabbit hole of what can work and what can't work and how the hell it's going. All right. That's pretty much all I have for PowerPoint. We are now going to delve right deep into the code. Fair warning before we do that, the first part of the parameter binding sequence and analysis, we're going to look into how we're looking into this, but we do not have all that much agency to do some fancy magic there. So this might be somewhat dry. I'm trying to make this entertaining, but if you're feeling like, Fred, you could do better, the second part is going to have Fred magic. And some bragging about my toys, but I think most of you knew that was coming. So, the first thing as a starting point, as an orientation point, we will be discovering and analyzing that right away. But there is a certain process in which PowerShell processes all of the bigger, and proper color, damn it. Give me one moment. And color theme, and let's go this in a proper way. And there we are. Readable? Excellent. So when we specify a specific parameter by name that takes precedence over everything else, then we have positional parameters. Then we go back to dynamic parameters if you're using them. There are some legitimate use cases, but usually I have some prejudices against that. And do the same thing again for dynamic parameters. And then finally, way later, we do the pipeline input. The pipeline input, let me close this one, we won't needing that, and the mouse is going to keep scrolling down. Pipeline input happens later during processing. The PowerShell has already run its way, so we'll be looking into this later. And that happens then. So, first of all, if we want to analyze this in any kind of depth, we need something that allows us to look at what's happening there. And there is a command built into PowerShell itself that allows us to do that. The only problem is it's not all that user-friendly. The command that I'm talking about is trace command, where we can add a debugger or write to log or to console screen exactly what's happening in which step, whatever, but we need to know what the step is named, what it's called, what we're looking for, and then filter down the results. So let's take a very simple command to remove any distractions and take a look at what that would look like in a bit more console screen, because now it's going to be a bit more there. And fire. So now we have, with a timestamp, every single action that's being taken. And we can see here we are binding the argument 24 to the parameter param1. Then it's going to try to convert it to the correct data type that is system object, because we didn't specify anything. And then it realized, oh, it's the correct type, it doesn't need to work, so the binding is successful. There will be situations where it's not successful and where that's fine, where it's going to be skipped. We'll be looking into that. And, well, we can extend this. Let's see what happens when we try to bind two parameters. Param2 does not exist. Param2 does not exist, so now we are trying to provide something that, well, should not be working. And surprise, it worked. There was no problem, there was nothing. But also, the parameter was not bound. We only have the first parameter. The second parameter that we fictionally specified would not do anything. So, what's happening here? This is a function without a CM-delete binding, without a parameter attribute, in which case it simply ignores everything that does not exist on the parent block. Which also means that if you have a typo in your script, you're not going to get an error that something broke. So if it's only for, even if it's only for that feature, add a CM-delete binding, and we will at least see proper failure. Reload the function. And now this is going to be a less happy experience because this doesn't work. Of course, you're seeing a lot more messages. We'll be going into them into a bit, because we now had a lot more parameter binding that is involved when trying to write the red error message on the screen. There are a lot more commands there. So this going always with trace command and then having debug messages to read of the I, that doesn't really work well with me. So I built a command that does the parsing for me and provide all the information that I need. You can see that here. We are basically creating a temporary file and have a trace command not dump on the console screen, but into the file. Then we read the file, delete the temp file, and finally process everything into objects that we can work with. So with that, we have some basic analysis capability. We'll be going to the PS Gallery soon once I have added some more data from home, where there will be a bit more parsing and better intelligence. But we'll be looking at mostly the raw data today to see what's actually being sent there. So let's add that. And now we get to see all of the items that happened in that binding. Step by step, with commanded binding, we have more steps. For example, so at the beginning, it shows us how many arguments were found. Then we have the named binding phase, which is what we did here. We named the parameter, and we did the coercion, and it worked, and we had a successful binding. Then we are looking for positional binding. Since we don't have any positional arguments, that's OK. We resolve the parameter sets. We don't have any specific parameter sets, so it's generic. We check whether there's any mandatory parameter missing, so we can prompt for it. Isn't there? No problem. And then we execute the command with the three phases. On the left side, you see the timestamp starting from the beginning of the parameter binding process for that command. As a tribute to Bruce Payette, yesterday's session, that the PowerShell parameter binder is somewhat slow. We'll be seeing a lot larger numbers by the time we're done here. So, simple binding experience. I've got a command prepared to allow that for us with some explicit parameters, a mandatory one, two positional, one of them is neither. And it doesn't do anything. It's really only to demonstrate the binding process. So if we now execute a bind, again, we are doing the type conversion. At the beginning, we bind it to the param1, convert it, call the conversion logic for that. We'll be seeing that later in action, how to manually call that. There will be a case from type conversion. It's converting it to string. That worked. we generate the data, we try to convert it again, no coercion is needed, all the conversion processes worked, it's the correct type, success. Then we execute it, and now here's something happening. We add param2 and param3 that were not specified. The parameter binder is also involved in providing the default values for parameters. So if you have a string parameter that you don't provide values for, that it's always an empty string, not a null object. Or numeric parameter will always be, parameter will always be 0 if you don't provide it. That's happening in the parameter binder, because at the PowerShell engine level, all of our variables and types are kind of an abstraction layer of the PS object, so they are not the actual primitive types that by the C# and common language runtime cannot be null. So PowerShell has to step in there and make that happen for us. So if you're analyzing the troubleshooting and you're seeing a lot of null assignments and empty values, that's just PowerShell parameter binder filling up the missing bits. Positional binding is the same thing again, only that after we finish with the named binding and do the value 24, we switch to the positional binding step, and now we are matching values to parameters that are still available that accept positional values. So far, I think most of us already had figured that out by experimenting with the console, but here we can see the details happening. And a lot of other things. Now, what happens when we have mandatory parameters that we do not provide? I'm just going to use param2. Param1 was mandatory, but I did not provide it. What happens here depends on whether the console knows, oh, it's an interactive console or it's an automated task. If it's automated, it's going to error out with an error. In our case, it's going to ask for that input. Here's one thing, we didn't see anything yet. That is because the trace command is finishing for the command execution, and only then it's going to process items. So I now need to provide a value. Let's go with my universal answer. And we have quite a bit here. Oh, select object. Where's select object coming in? This is one of the traps that happens if you are thread and using thread tools, or if you are otherwise in the habit of using parallelization. Trace command captures all the events that happen in that PowerShell process. And if you have a background run space, which happens to be an internal logging cycle, which happens when you have PS framework, there might be some artifacts in there. So let's go ahead and do the stop PSF run space, and I'm stopping my background run space. So now I only have one active run space that's going to do something. And try again. It asks for the value. It gets a value. And now we have a lot smaller output. We have, again, the named binding phase, where we add the value to param2. We have the positional binding phase, which doesn't do anything. We resolve the parameter set, which is kind of important to note that we first resolve what parameter set are we working with before it starts prompting us. So if you're wondering, why is it prompting me for the wrong parameter, the wrong mandatory parameter, you want to look into how your parameter set resolution happens. And then finally, we have the mandatory parameter check and prompting for missing mandatory parameters. And bind it by that, and do the type conversion, and do the type conversion for the parameters that we didn't specify until we're done. So, what happens when we do something that doesn't work? I mean, we're troubleshooting. We're usually troubleshooting when something broke. So let's break something. Actually, we provide a value parameter, but no value, and the parameter is not a switch parameter. This is not going to work. And there, well, we get results, but it's set strict mode. It's format default somewhere in there, error action preference. There are show binding extended. What's? Of course, now it dumped everything on me. Demo gods, how do I love thee? Okay. Awesome. Anyway, we get a lot of dump on the screen that we have to parse through to make this somehow work. In my experimentation, often enough, we don't get the actual binding part. I did mention that I have this command here for tracing, which is in a PowerShell module that is going to the gallery soon. What is also going into that, which I have accidentally left at home, is a command to parse a parameter binding statement and figure out what's going to go wrong. Like analyze, this is the error, this is why it's happening, this is the parameters that you're going to get because of X, Y, Z. So an analysis tool will be soon on the gallery for that, to clean up the output, because reading that by eye is something I too don't really like doing. So we have one more sinner, and that's a real sinner, and that is dynamic parameter binding. Dynamic parameters are historically misused. We have some original guidelines on how you can dynamic tab completion for PowerShell version 2, where that involves building a dynamic parameter with a dynamic validate set. In PowerShell version 2, that was more or less the one way to get that done. Since then, we have a lot better options, but since dynamic param and dynamic tab completion kind of have a high hit rate on Google or similar tools, you will be getting a lot of results, and people have been perpetuating that. It's great for component-based, plugin-based development, extensible code design where you don't know everything, but it's frequently used badly. So we have a dynamic param, which includes two parameters. One of them requires the param1 to have the value foo, and the other one requires the param2 to have the value bar. One of them has the positional attribute. We'll be investigating this in a bit. The other one is a plain parameter, nothing to see there. So let's get that loaded up and analyze what's happening when I provide the values all positional other than the param1. So we have 4 arguments, so far correct. The param is also an argument as far as the parameter binder is concerned. We are binding explicitly first param1 because named binding comes before positional binding. That works out well. We again go to positional binding, and we start with param2 for the value 42. That works. We complete that. And then finally, we start building the dynamic parameters, because the dynamic parameters are executed after all the other parameters are provided. So it can make confident statements that this is the dynamic parameter that's supposed to be available when you make your dynamic parameters depending on something else that's kind of important. And then it finally binds the value to 23 to the dynamic parameter class. Here's one thing to note about this. The parameter class has a positional rating of 2. The param2, however, is a positional rating of 3, which means in an original traditional binding order, class should have been bound before param2 because it has a lower positional number. However, the PowerShell parameter binder will not honor the positional rating of a dynamic parameter outside multiple dynamic parameters, because dynamic parameters are being resolved later. So if you like messing with positional binding and you start dabbling with dynamic parameters, don't be surprised if it doesn't work out the way you hoped. And that's totally didn't happen to me. Yeah. If we execute everything, we're not going to look at the same entire config again, but the key part for dynamic parameters is the same rule that they go with named dynamic parameters before they go for positional. So they honor the same processing equivalence. Which leads us to one of the favorite PowerShell techniques of mine that I hope everybody is familiar here with, splatting. Splatting is one of the greatest productivity tools that we have in coding because it allows us to dynamically bind values to parameters. We have a quick demo. we can either do get child item with explicit parameters all, or we could do the same thing by providing a hash table that has the same keys as the parameter names and the values for that. Switch parameters are Booleans in that context. And we can bind this with an add. One thing that is often overlooked is that we are not actually constrained to a single splat. So I can provide a second hash table with a new parameter and splat them both. And it works. Yeah, which leads us to, well, how does that look when we investigate the actual binding process? And other than additional numeric conversion going on here, thank you, PowerShell. There we go. We have 4 arguments, even though we actually only provided, no, actually did provide 4, that's great. We have named parameters. One of them is path, one of them is force, and one of them is file. It's bound to dynamic parameters because, well, file is a dynamic parameter in getChild item, but it is a named parameter. At no point in this log will you find anything about splatting. The entire splatting is resolved before parameter binding ever happens, and they are treated 100% the same way as regular named parameters, including that you should not supply the same parameter multiple times, which is going to get more red stuff on your screen. So we have got splatting. Splatting is convenient, so time for a little bit of advertisement, how to make it even more convenient. In my favorite module, PS Framework, there is a tool to make splatting more approachable. We have an original hash table, like, for example, the PS-bound parameters, and we can ask for another hash table with just the parameter properties that are needed to splat to this particular command. And with that, we see we get exactly 2 properties out of it. The category thing is not a parameter on getChild item. So, pipeline input. Quick one there. And if we do the same thing with pipeline input, it shows the similar aspects. Do this right. No. Of course, no pipeline binding. Yeah, it's no change, just because we support input from pipeline. As long as we don't provide it, there is nothing happening. If, however, we pipe via pipeline into the parameter, we can see the pipeline binding process happens a lot later. We start with the regular named parameters, which is great, it works. We have the positional ones, which we did not provide, so resolved parameter sets. We currently have the current parameter set name, that's important prefix, current, because we then go to the pipeline parameter after we start begin processing, and we start process record, and at that point we bind the first value, 1, go through it, it's executing completed, then we reset, go back to the next object that we're piping through, then we reset, go to the next item until we're done. So, there is one more thing about pipelines that is also entertaining, for me at least, is that you can provide a script block to a parameter that accepts input from the pipeline. And if you do, it is going to execute that based on the input object. A typical use case is rename item. I want to rename an item based on its original name. In this case, I want to prepend 2 zeros and an underscore. And that will work. So we don't have to leave that parameter free and take it as we receive it. We can customize based on the input object dynamically during parameter binding. And if we execute that in the trace, we will see that happening as well. But mostly we see it executes the script block and then generates the data, which is 2 times 2, 4. So that from a binding perspective, it's one more step. Of course, one more step that can fail of an exception, because script block, but yeah. All right, last one on the pipeline and how it's bound. There's one special way we can execute a pipeline that's called a steppable pipeline. Anybody here using steppable pipelines? Okay. I see this is something you can take away as an immediate win. Don't worry. We will get into that. First of all, we're showing the problem that the steppable pipelines are solving. It's a problem that is very, very low-tech and happening in everybody's scripting every day. And that is, I have now a custom command called export CSV custom. And I'm going to export to CSV. I take the input, and I'm piping it to export CSV with the path, some delimiters, some extra parameters, and an append, so I want to add it at the end of the file. Let's load that up and execute this. I'm taking all of the items under the windows, and it took me 1.7 seconds to generate one bloody CSV file. 1.6 seconds for, I don't know, 200 items, 300 items, something on that order. That is too slow. What's happening? When you set an object to export CSV, it takes the first object you're piping into it, parsing the properties to get the headers it's needing. Then you export it to a file. That file already exists, you want to append. So you need to open the file, read the headers, compare the whole thing, scroll to the end, write the file, close it. And by having that in the pipeline, we are now doing this once per item that we're sending, and that is expensive. Also, this leads us to the second problem that we often see is that we've got an antivirus that, oh, there's a file being changed, let's check that file out. And that moment you want to write the second entry and the file is locked. Yeah, not so great. So how can we solve this? This is where steppable pipelines come in. And that is, we first create a script block that just contains the export CSV command, not the objects you're piping to it. And script blocks have this this method called getSteppablePipeline. With that, we have like a currently running pipeline that is paused, and we can just tell it to get started whenever we feel like it. Which we do in the begin block by calling begin. The .begin is important, and we need to provide it a value, either nothing, true, or a $PSCMDLet object, which is our own function environment of the export CSV custom 2. If we don't provide true or that value, the steppable pipeline will assume that it isn't supposed to receive input, and it will receive input, which kind of defeats the purpose. So we call true, which means, hey, I'm going to send you input, I'm going to receive the output, and I am going to do something with that output. If we do $PSCMDLet, it will instead produce the output, and our own command cannot interact with that output. So usually, by default, unless you have a specific reason not to, use true. Then, in the process block, we call process on our steppable pipeline. And finally, at the end, important, we end it properly. Let's do the same thing again. We had 1.7 seconds for the first one. And for the second one, it's, well, 50 milliseconds to do the same thing. The file was kept open and locked. The antivirus was unable to kick us out. We did not need to use append all the time, which means we start a new file at the beginning of our execution and close it at the end, which is another thing that we often have, that, oh, the first time I don't want to append because I need to remove previous files. Well, that problem is gone. And, well, we can now send this whole thing through the tracer and see what happens. And it is the exact same thing that we saw before, only the begin phase right now, like binding named parameters. We have provided a few, so it's doing quite a few conversions. That's OK. And then we can inspect a single one process item happening with the type conversion, what's happening, what is the result, where did it fail or work, and so on until we're through. All right, I misjudged the time. Okay, apologies about that. I mistimed the whole thing. I'm going to skip the more detailed binder things like how exactly the parameter set resolution happens. We are running out of time for that, sorry. There is one quick show about parameter sets in the pipeline that is frequently unknown and is important for design decisions. I have a command that takes 2 items from the pipeline, and it will print on screen what is the current parameter set that's running. One of the items it accepts is a file, the other one is a directory. And if we now send this through, you can see that we in the start phase, in the begin phase, we have on all parameter sets we don't know yet. In the process block, we have, depending on each item, a different parameter set. If we have multiple parameters that accept input from the pipeline, and we send items, a mixed bag of items through that, every single process phase might be a different parameter set. So if you make decisions based on the active parameter set name, you probably should not be doing that in begin. Not going to end well. So, another one that is a bit more hands-on. What happens when I have not different parameter sets, but I do accept multiple values from the pipeline? Multiple parameters that accept, like input object, name, or full name that accepts only by property name. That's OK. In that case, every single parameter that accepts from the pipeline gets values. So if you're like, oh, I'm expecting only the main object receiving that, and by property name only if I have something matching and it doesn't have the main one. No, every single parameter that accepts from the pipeline is bound if it can do it. Which also adds to the performance cost if you have a lot of objects that you're sending through and it's trying it for everything and it doesn't work for everything. So building small functions can really drive your performance and reduce the cost there. Last one on the boring list, but it's hopefully not quite as boring, especially it's shorter. What happens with parameter binding when we actually don't run PowerShell commands? Classic ping, I mean, I think most of us have used that in our time. We have a completely different binding process. It's a lot more lean. Everything is named, and hopefully it works or not, but that's not our job as PowerShell anymore. It's something that happens with the application. We have one more entertaining one. This operator, --% disables the PowerShell parser for the rest of the line. It means if we need to provide a value exactly literally so as we have it in script to that external application, we can disable that from happening, the PowerShell from interpreting it like parentheses or quotes, and send it over to the command as originally intended. Let's do that with the ping. Works exactly the same way. The --% is not sent to the application. It's swallowed. And if we now add quotes around this one here, this is something that PowerShell would be interpreting. The quotes would be gone, usually. With the --%, it's sent literally to the target. Which is also a nice way to analyze, like, what did the application actually receive when it's complaining about bad input? Because I think the trace for external applications is really readable. Which leads us to the next one. External applications you can pipe to. If you have like a disk part or an lookup that have an interactive console, you can send pipeline input to them to give them a command sequence and automate it, even though the command line application was supposed to be interactive only. If we send this to the tracer, it starts the native application with 0 values at the beginning. Native application argument count 1, nothing sent in there. And then we process out string. Before that, because PowerShell implicitly use out string to ensure we only send strings to the application, does some processing and formatting around it, and at the end sends it to the application. The actual pipeline binding is not shown in the tracer, because that is actually not really parameter binding per se. It's calling a .NET method that is added for us implicitly. So it doesn't show up in the parameter trace here. And yes, this totally means we can send disk part statements. I won't run this right now, not elevated. It's going to have a problem. And there's a nice PowerShell module, PS native, that I totally didn't write, that allows you to have an iterative, interactive experience with a console application. Get that particular one. Come on, PowerShell, you can do it. So it is now our disk part, and I can then send it commands and see what it got me. So you can step through an interactive console and wrap it around with that. Not really PowerShell parameter binding, but some form of parameter binding. So, yeah. All right. The binding process survived. From a type conversion thing, there is something I should be talking about here, and that is there are two ways PowerShell converts data. Option one, I just have a regular parameter with a string or int or data type, whatever, and PowerShell tries PowerShell type conversion. If it does that, it's not quite as simple as a cast in C#, but it's fairly close. If we already have the correct type, nothing happens. There are language-specific rules about the simple types like bool, string, that are optimized conversion processes because they are the most frequent and performance matters, so there are some custom rules for that, which of course had led to some idiosyncrasies when somebody tries to play with the process, which I totally did not do, and a certain person in this conference still owes me a beer over his date time handling. But yes, if you follow the rules, the next one after that managed to actually leave the most important out. If you have a constructor with on the expected type, a constructor with a single parameter, that is the input type, PowerShell tries to run the constructor. Which also means that if you have a hybrid module or doing C#, do not put any major logic into the constructor because PowerShell will run it even if that fails. So you might be causing a lot of parameter binding costs right there without any chance for success. So be wary what you do in your constructors. We can have type converters. PowerShell has a concept of type converters, of registering logic, how to convert something from A to B, which is mostly useful if you're trying to prevent deserialized objects across PowerShell boundaries. Definitely out of scope for today. And finally, we can also do implicit, explicit casts in the C# type system or implement an I-convertible interface, which means if I write my module and I want my output to be understood by the other module, I can try to enable one of those paths so it works. I do have a session on enabling exactly that about parameter classes. We have that recorded on a PSConfEU. I don't quite remember the year, 2018, something like that. The link is in the docs. The other option is when somebody provides an argument transformation attribute. When you provide an argument transformation attribute, you are telling PowerShell, you know what, PowerShell? I know better than you. This is my game. I know how my command is supposed to work, and I'm going to tell you how to convert this. If you do this, you disable the entire PowerShell conversion process. It doesn't do a thing. I've got a simple example of how that can go wrong. First of all, there are quite a few such attributes at hand. Because I reduced that too fast. So PowerShell ships with quite a few of them. The most well-known culprit is the credential attribute that makes sure that this pop-up of the credential window happens in Windows PowerShell. So I'm not going to show parameter classes. That's definitely out of time. Sorry. Argument transformation attribute. I've got a number transform attribute. I'm telling, hey, I know how to convert numbers. If it's an integer, I return it as it is. If it is double or decimal, I'm going to truncate it. Not round it, truncate. Otherwise, I'm going to throw an is invalid data error, and that's that. So I now know better. I've got a function that uses this attribute. So I can now provide this command, it works, it has the number. If I provide this double value, it should now truncate everything. And I've now provided a number that is actually a string. Under default PowerShell, this would not be a problem. But oh, you knew better. I knew better, so now we live with knowing better, which is a good feeling. So if we actually think we have a use case where we need to do this, where we really want our own transformation because the basic PowerShell transformation just can't handle what we need, there is one thing to take away from this. If you do this, please manually call the PowerShell transformer at the end if nothing else worked. Because you can tell PowerShell, OK, let's give you a try anyway, after I've had my chance. The way this works is pretty much exactly the same way, only that we now call language primitives convert to at the end. By adding this line, we tell PowerShell, OK, do the PowerShell conversion if I couldn't make it. Load it up. Function definition on that. And that's it. If we inspect the trace on that, we have the detailed conversion logic in here where it shows us that it now is calling the transform attribute. So if you have a command and its type input behavior is weird, the trace can tell you that it actually had some custom transformation rule that extends or overrides PowerShell argument transformation. So last one. Sorry that I'm really cutting close and not leaving much time for questions, so totally ambush me on that. We have one common issue that we encounter. Again, I get lots of tickets every single month, questions from customers about that. And that is the good old cannot convert object thread of type thread to type thread. This happens especially frequently when we have PowerShell classes. PowerShell classes are a quick way to get something like a C# class, only you don't have to learn C# first. Which does have its moments. So defining the class, that's great, hopefully. I'm having a function that expects the type thread as input. I create the object, and voila. Worked. Great, so far that's awesome. But now we have the next test, so I'm defining the class, maybe with some modifications again. That's great. Yeah, we have the same. We've overwritten the old function. The old class. PowerShell classes can be redefined without having to restart first. That's really convenient. So I now load a new function with the new type. And bam. What happens is when you define a PowerShell class, it dynamically generates an in-memory assembly, gives a dynamically calculated name for your class, and the thread, the visible class name you picked, becomes kind of an alias for the name. And when you then define a PowerShell class with a PowerShell function, if the class is a parameter, it resolves that alias at define time. So this new function points at a new class, which is a different class than the class that defined the object that we previously generated. Reimport the module, have some other funky going on, and your object is no longer the same type, even if it has the exact same properties. So, of course, this would not be a thread talk if I didn't end with a thread toy. So there is something in PS Framework that has an argument transformation attribute that knows better. You can tell it what your target type is, what properties you absolutely must have on the object in order to work, and then it will do the conversion for you. And yes, it also implements PowerShell conversion. So, thank you for your patience. I know it was somewhat of a dry spell some part of the session. Any questions? All right. If there's nothing else, thank you for joining. And you know where to find me. Feel absolutely free to hunt me up with additional items when you have some time to digest the whole thing.